All right, so this is 18.4 part 2 to make sure you're in the right spot. So these are the reciprocal functions. Reciprocal functions mean that they reciprocate. So like the reciprocal to 1/2 is 2 over 1. Reciprocal to 10/11 is 11/10. So those are reciprocals, and luckily we have reciprocal functions, trig functions. Now, you'll not see them in the calculator. If you want to find them, you have to do 1 over this. You find the sign and then do 1 over the sign in order to use your calculator and the N over D button and type in 1 over sine of the angle instead of cosecant itself, which is a little trickier, but I mean, they just don't put in all the ratios for these reciprocal functions. They're not as familiar, and you can take care of everything with the other ones just easily with sine, cosine, and tangent because they relate all the sides. And the reciprocals are there for specific things. Want you to be aware of them. When you get into calculus, you'll use them more. So it's good to have a background knowledge of them and understand what they are. So the sine theta, remember, is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Sorry, they moved. I'm sure when you write them down on yours, they'll be fine. Cosecant, secant, and cotangent are reciprocals. Now, I always remember these by, first of all, tangent and cotangent are very easy. So the tangent's reciprocal is cotangent. It's also the cofunction, which you'll learn later as well, but not this year. But tangent and cotangent are reciprocals of each other. So with the cotangent being 1 over tangent, the cotangent is actually opposite over, or sorry, adjacent over opposite. I got to erase that. And I don't like how that turned out. That's kind of where I did my focus, opposite over adjacent. All right, so cotangent is 1 over tangent, which actually makes it adjacent over opposite. Okay, those are easy to remember. Tangent theta is 1 over, is cotangent theta. Tangent is reciprocal is cotangent. So cosine's reciprocal is secant. So secant is 1 over cosine theta. That just how is what it is. And if you do 1 over a over h, then that flips up and multiplies, which makes it h over a, right? So hypotenuse over adjacent. And the same thing happens with cosecant. You get 1 over o over h. You flip and multiply and get h over o. So cosecant is hypotenuse over opposite. Now, the way I remember these, oddly enough, sine, cosecant are reciprocals. Okay? Notice they have the not the opposite, but the other letter. So the reciprocal of sine doesn't start, secant starts with an S, but it is not the reciprocal of sine. It's the reciprocal of cosine, secant is. So sine's reciprocal is cosecant. It doesn't start with an S, whereas cosine that starts with a C's reciprocal does start with an S, it's secant. So the reciprocals don't start with the same letter. So you just have to memorize cosecant. And when asked, well, what's the reciprocal? Cosecant starts with a C, so its reciprocal is sine that starts with an S. And that's how I always remember it. So you can come up with your own way, but that seems to work the best for me. I always think, okay, sine. Sine is O over H. And I think, what's cosecant? Cosecant is reciprocal of sine, so it's, instead of over H, it's H over O. And then I can just flip whatever the sign is, and that will give me my cosecant. All right, find all 6 trig ratios for theta shown in the triangle. This kind of, it's just gonna, I can't really change it. Let me write this, see if I can get it all on the same theme. So anyway, we want all the trig ratios for these. So let's see, select objects. Let's just, dang it. It's going to waste some time here trying to get everything on one slide. This is homework. Oh, well. All right, so find all 6 trig ratios for theta shown in the triangle. So if I can just bring this down, maybe I can. Okay, so what we need first on here is we need the side, the hypotenuse. We don't have it, but we know Pythagorean's theorem, and Pythagorean's theorem says if I take the square root of 12 squared plus 5 squared, then I can come up with that side. So you might have to come up with the third side. Always remember that you can use Pythagorean's theorem to come up with that. And that is the square root of 144 plus 25, which is 169, giving this side the measure of 13. And I kind of have to write it down there because I don't know. Will it write? Oh, it does. How sweet. And it doesn't even move. How fortunate. All right, so that's 13, and that's our angle. All right, so from that angle, we want to find the sine, cosine, and tangent, and cosecant, secant, and cotangent, which shouldn't be too difficult. Sine is opposite over hypotenuse, so before I do anything else, what I would do is I would mark the hypotenuse, give it an H. Opposite is going to be the leg opposite the angle, and then adjacent is the leg adjacent the angle, which is 5. And then you can remember SOHCAHTOA. So sine is opposite over hypotenuse, and that just kind of helps you remember. So opposite is 12, hypotenuse is 13, and then I just go ahead and flip it around for cosecant. It's reciprocal, 13 over 12. And then the cosine is adjacent, so that's 5 over hypotenuse, 5 over 13. Secant is its reciprocal, so just go ahead and write 13/5. It's hypotenuse over adjacent. And then the tangent theta is opposite over adjacent, so 12 over 5. And cotangent is its reciprocal, 5/12. Okay. All right, next one, I'm going to actually just draw it, if it will let me. So given the ratio for cosine theta, find the remaining ratios. So we're going to have to draw our triangle here. We'll put theta right there. Okay, and it doesn't matter which one as long as you line up the angles with the sides appropriately, such as cosine is 2/3. So we know that this is the opposite, this is the adjacent, and this is the hypotenuse. So adjacent over hypotenuse is cosine, adjacent over hypotenuse. So that's going to be this adjacent side is 2 and the hypotenuse is 3. And then we don't know the opposite side from theta. So we can find that using the Pythagorean theorem. And this is the leg we're looking for. So we'll take the hypotenuse squared minus the leg squared, which is square root of 9 minus 4. So this is going to be square root of 5. Now, if it's square root of 5, we have an issue sometimes because it might be in the denominator. Now, I want to write this angle over here because I don't want to, it might not let me because I'm going off the, oh, maybe I'll just write it. Can I write it up there? Or will it erase? Woohoo! So I have theta, I have opposite is square root of 5, the hypotenuse is 3, and the adjacent is 2. Okay, and then I can get this out of my way here. Remember, we used Pythagorean theorem. We were missing a side. We had to use that, which is fine. Okay, pen now. Thank you. All right, so right off the bat, we know, oh, did I write that again? Did I find adjacent? Yeah, adjacent over hypotenuse. Okay, so secant is its reciprocal 3/2, and we're done with that. Now, sine. Sine is opposite, which is radical 5, over hypotenuse, which is 3. And then the cosecant is the reciprocal 3 over radical 5. And this is why I don't like getting radical 5 for a side, because I know eventually I'm going to have to, when I do a reciprocal or find any of the functions, I'm probably going to have to rationalize somewhere, which in this case I do. Have a radical 5 in the denominator, so that makes 3 radical 5 over 5. Remember, to rationalize, you multiply by the radical itself. We learned that more toward somewhere in first semester. So anyway, easy to come up with a sign, but then you have to reciprocate. And when you reciprocate for the cosecant and you end up with a radical in the denominator, remember to rationalize. All right, tan theta is opposite over adjacent. This is our angle here. So opposite is radical 5, adjacent is 2, which is great. But when I reciprocate it, 2 over radical 5, I have to rationalize by multiplying by radical 5 over radical 5, which gives me 2 radical 5 over 5. Okay. So that's how you would come up with your 6 ratios. Now, how do you remember all 6 ratios? My guess, and you have to write in here what you want. but I remember SOHCAHTOA to help me with the original 3. And then the reciprocal of SOSINE starts with C. Cosecant theta, reciprocal of cosine that starts with a C, actually is secant. And the reciprocal of tangent is pretty easy. It's just cotangent. So that's how I would remember them, but write it out in your own way. And that is the end of 8-4.